Hey everyone, and welcome. Have you ever stopped to wonder how an AI, like the one in a self-driving car, can look at the world and actually, well, understand what it's seeing? Today, we're going to break down the one fundamental building block that makes it all possible. And you know what? The core idea is way simpler than you might think. So let's stick with that self-driving car example. It's got to make a critical judgment in a fraction of a second. Is that car up ahead in perfect condition, or has it been in a wreck? How in the world does it tell the difference? Well, the answer isn't some kind of unknowable magic. It's all rooted in a concept that's actually pretty straightforward.
And that's really the secret. For an AI, everything it sees, from the shape of a stop sign to a dent in a car's bumper, isn't an object, it's data. And every last piece of that data gets translated into a massive, highly organized system of pure numbers.
And that organized system of numbers? It has a name, a tensor. Now, this isn't just some fancy jargon. It is the fundamental data structure in deep learning. You can think of tensors as the language that AI models use to interpret our world. So if you want to understand AI vision, you've got to understand tensors.
So to really get a feel for what a tensor is, we're not just going to define it, we're actually going to build one from the ground up. We'll start with the simplest little piece of information you can imagine, and layer by layer, we'll construct the data for a full-color picture.
Okay, our starting point is dimension 0. This is a 0D tensor, which we'll also hear called a scalar. The best way to think about it is like a single atom of information, just one number, all by itself. It doesn't have any length or width or depth. It just exists.
Like, say, the number 21. By itself, it's just a value, but it could represent anything, right? The temperature, someone's age, or maybe the brightness of a single point of light. This is our most basic building block.
So what happens when we start stringing these single numbers together? Well, if we take a bunch of these 0D tensors and line them up in an ordered list, what we get is a one-dimension tensor. You've probably heard its more common name, a vector.
This is a really important step up. We've gone from just a single point to an entire sequence that has an order. This vector now has one dimension. You can think of it as length. It's no longer just one value. It's a whole line of related data points.
Okay, you can probably see where this is going. What's next? We take those 1D tensors, those vectors, and we stack them on top of each other. And that creates a two-dimensional tensor, or what's usually called a matrix. So now we've got a grid that has both length and width.
See how each row here is just its own little 1D tensor? Together, they form this grid. And this structure, this is incredibly powerful. It's perfectly designed for the super fast math that makes neural networks tick. But even better, it can directly represent something we look at all the time. Exactly. A 2D tensor is basically the perfect digital blueprint for a black and white photo. Just imagine it. Every single number in that grid represents one pixel. A low number? That's a dark spot, maybe pure black. A high number? That's a bright spot, maybe pure white. And all the numbers in between? Yep, those are all the shades of gray.
All right, that's a huge piece of the puzzle. But let's be real. The world isn't black and white. So how does this whole system of grids and numbers manage to represent all the vibrant colors that we see every day?
The solution is actually pretty cool. Instead of just one grid, we use 3. We make one 2D tensor just for the red values in an image. Then we make a second one just for the green values. And finally, a third one for all the blue values. Then you just stack them right on top of each other.
And that stack, that is our 3D tensor. It has length, it has width, and now it has a third dimension, depth, with one layer for red, one for green, and one for blue. And that's it. That is how a computer sees a full-color photograph, as a single, three-dimensional cube of numbers.
But here's the thing. The power of tensors doesn't just stop with images. This whole idea of turning complex information into structured numbers is what makes so much of modern AI even possible.
This is basically the universal translator for AI. It really doesn't matter what the original data is, the pixels in a video, the sound waves in a piece of music, the words in this very sentence, or even stock market data. All of it can be neatly organized into a tensor, ready for an AI to analyze and find patterns.
So when you zoom out, that's the big picture. For an AI, the incredibly complex, messy, and beautiful world that we all experience gets translated into the clean, logical language of numbers, all perfectly organized inside these powerful, multidimensional containers.
And that really leaves us with a fascinating, kind of mind-bending question. If any part of our reality, What we see, what we hear, what we read can be encoded into a tensor. What does that mean for the future? What new patterns could we teach an AI to see? What problems that we once thought were impossible are now suddenly within our reach? It really makes you think. Thanks so much for tuning in.